Hello everyone, my name is Elijah Proctor and today we're going to talk about descriptive statistics and how I basically answered the 8 tasks for the assignment. And so just a little disclaimers that we did use a little bit of generative AI for templates for some of the Python code and the plotting, but I rewrote it to fit and answer the questions as best as I could. And so since there is a lot of code and there's a lot of stuff to get through within a short amount of time, I'm just going to go over the summaries that I had written for each of these Python scripts, and then I'm just going to showcase the graphs and visuals that I have, and some of the stuff that I have printed as well. And so this code uses the z-score and IQR methods to detect and manage outliers in a data set, and this ensures the data set is appropriate for numerical analysis. The script reads it from a CSV file, and it reads this column called study time weekly, and so that's what we're using to find outliers. And so there's two functions, the get the z-score and the get the IQR outliers. And to find the outliers using the z-score and IQR approaches respectively, these functions compute the required statistics, the mean, standard deviation, and percentiles, and identifies the data point significantly varying from the central tendency. And so we have visualizations using the scatter plot to show the z-score algorithms that the z-score basically identified the outliers that exist in the data set, and then we have a box plot to display the distribution and existence of outliers. And so this is the code here, and here below we have our box plot, and then we have our scatter plot just to showcase the outliers that were found within the z-score, and then we have our printing of the size of our data set after we have removed the outliers. Okay, so here we have, to answer task 2 is basically talking about bias and confounding variables, and so these are the references I used to answer this question. And so there is bias from reporting, measurement, and selection sources, and they may be present in the student performance data set. And so the selection bias arises when a data set does not fully represent all students, making it impossible to generalize the findings. Measurement bias results from errors in self-reported study time data, which skews the relationship between study time and performance. And so potential confounding variables include socioeconomic level, family involvement, prior academic achievement, teacher quality, and school resources. So these are just examples, and then I have listed the references that I used to justify this answer. For task 3, we talk about handling missing data. Effectively managing missing data is important to preserve the accuracy of analysis, and so we use a technique called multiple imputation. And so this is just something that I had researched, and I had used this skikit-learn documentation in order to write this Python code, and then we also used this flexible imputation of missing data article in order to implement Rubin's rules. And so I do not understand honestly, I do not understand the code completely, but I was able to get a working Python script, and I'm able to display the results that were found by using the imputable mutation in order to answer this question, in order to find the missing data or handle missing data within a data set. And so we're using the student performance data set just like before. And here is the missing data summary listed here. The fourth task is analyzing the mean and median values, and so it loads the CSV file, which is going to be online courses uses.csv. And in the script, it is vital to have, it has extensive error handling for potential problems, just like all the other scripts. And before conducting additional analysis, the data set is successfully loaded. Any missing data is checked for, and the summary is printed to guarantee data quality and completeness. And this is an essential step because missing data can seriously affect how reliable statistic measures like the mean and median are. And the primary analysis entails computing the dataset's mean and median values for numerical columns, emphasizing the price column to illustrate any discrepancies. Okay, so there is a lot of code here, so I won't go over everything, but we do use basically we have the transform data, which is use log transform data, and then we also graph the data without the top 1% outliers as well. And then we print the results at the end. And so here's us basically just printing the mean and median values. Here is our graph to just show the data distribution. And then we have our log transform data distribution as well. And then our data distribution without the top 1% outliers. For task 5, basically we're using the emoji usage dataset, and it uses a reliable load CSV that we've used previously, and it's including missing files and basically error handling for including missing files or corrupted data. The first few rows and a list of the columns are shown after dataset has successfully loaded, assisting in selecting the data that should be seen. Subsequently, the script concentrates on the user age column, producing a box plot and a histogram to depict its distribution. The frequency distribution of user ages is revealed by the histogram, which is improved with the kernel density estimate and the central tendency and variability, and it also includes outliers and depicted in the box plot. So this is the Python code here, and it has a lot of exception handling just in case there's any errors. Here's a little quick snippet of the data set that we have. Here's a histogram of the histogram of the user's age, and then a box plot of the user's age as well. For the 6th task, this is about measure of central tendency and variability. Basically, we're going to load this aapl.csv file, and we're going to list the columns and show the first few rows of the data set, and allow the user to choose which data to investigate. It computes essential measures of central tendency, the mean, median, the mode, and variability as well, and emphasizing the column that we use, the closed column. And these computations offer a thorough statistical synopsis of the data and facilitates a profound comprehension of its distribution. After that, the script publishes these measures, highlighting any noteworthy patterns or outliers and promoting analysis and discussion of the relationships to the data distribution. And so this is the code here. And so we're going to just show the first few columns in the data set, and then we're going to show basically the mean, median, mode, range, variance, and standard deviation of the closed column within the data set. Here we're going to talk about, for task 7, we're talking about data cleaning. This basically we're loading this CATS data set that has a bunch of messy data, and so to manage the missing data, the means of the numerical column, age and weight, are filled in, while the mode values of the categorical columns, breed, color, and gender, are filled in. To maintain data integrity, the script also eliminates duplicate rows. Following cleaning, the dataset information is displayed to confirm the modifications. And the script uses histograms for age and weight to visualize the clean data and show the distribution and effect of the cleaning process, emphasizing gains and consistency of the data. And so we're using, as I said, we're using the cats dataset.csv, and then we're going to handle any missing data values here, and then we're going to remove duplicates, verify the cleaning process, and visualize the dataset after it's been cleaned. And so here we go. So we have our age distribution of our cats, we have our weight distribution of the cats listed here. And so our last task is group analysis, and basically, by executing group analysis on a dataset, we're using the books data.csv based on categorical variable category. This Python script completes task 8. The dataset is loaded and cleaned, ensuring that all white space is removed from the column names and that the price TK column is changed to a numeric type. Next, the script organizes the data by category and computes the critical, central, and variability measures, the mean, median, and standard deviation, for each category's ratings and price TK. These group statistics offer a thorough synopsis of the data distribution among many categories, and to illustrate the results, the script generates box plots for ratings and price TK by category. These aid in interpreting the differences and patterns between the groups, facilitating the discussion of any noteworthy inconsistencies and insights obtained from the analysis. So this is our Python code that we had written, and here below we are printing out the results, and also here are the first few rows, just so you can just visualize what data is here. And here is our group statistics printed down. And the first histogram shows distribution of ratings by our category column, and then or distribution of ratings based on the categories that are in the data set. And for the next column we use is the price TK. And here is the distribution of prices by category. Thank you for listening. That is how I chose to handle the task for this assignment. Thank you.